So let's go ahead and take a look at some of the limit properties. And here's a list of quite a bit of limit laws. So some of them just kind of make sense. Some of them will help you out later on. Some of you do need to know. The sum rule and the difference rule, we're going to be looking at that. Constant multiple rule is a pretty simple one. So let's just talk about the sum rule. The sum of two different functions. If you have the limit of the sum of two functions, you could just add the two limits together. Same thing with the difference. You can just subtract the two limits. The constant multiple is actually an important one. It carries over into some of the other topics like derivatives and things. But the idea of the constant multiple is you can just bring that multiple out to the front and basically find the limit of f of x and then multiply it by k. And then the product rule, and then we also have the quotient rule, and then power rule and root rule. I don't think we're really going to go into those, but those are pretty straightforward as well. So let's go ahead and take a look at this. So what we're going to do is we're going to find the limit as x approaches negative 3 of h of x plus g of x. So traditionally, if you look at what we were talking about before, you could find the limit, let's just call the limit of h of x being L, the limit of g of x being M, and you could just add the two together. This doesn't always work out, and we're going to probably see an example of that, but for this case, it should work out. So let's go ahead and take a look. So limit as x approaches negative 3, so the limit as x approaches negative 3 of h of x, so that's this top one. As we approach negative 3, look, the limit is approaching positive 3. You see it on the graph as we get close to negative 3. That y value is positive 3. And then same thing for g as we approach negative 3. So that's right here. You can see that our graph is approaching positive 2. So the limit as x approaches negative 3 of g of x is positive 2. So we can just add those two together. So the limit as x approaches negative 3 of h of x plus g of x would be 3 plus 2, which is 5. Let's go ahead and take a look at another example. This one is just showing you that constant multiple rule because we're asking the limit as x approaches 0 of negative 2 times g of x. And basically the idea is you could just take that negative 2, bring it out to the front. Find that limit as x approaches 0 of g of x. So that limit, let's go ahead and find that. So as we approach 0, it looks like it's approaching 3 from both ways. So that limit there is just going to be 3. So we're going to have negative 2 times 3, which is negative 6. So once again, this limit here is negative 3. It's positive 3. So we can just substitute that in. Negative 2 times 3 is negative 6, and there's your answer there. Let's take a look at this one. Now, this looks like a little bit more complicated because if we try to split it up, let's try the traditional method, and you can see that the limit doesn't seem to exist. And it's possible that it doesn't, but we're going to split this up into two different cases. So if I try to think of this as the limit as x approaches 1 of f of x, just like we did in the first example, well, as we approach 1, that limit doesn't exist. But does that mean that we stop there? No. So here's what we're going to do. We're going to scrap this, and we're going to think of the left-hand limit of the entire thing. So the limit as x approaches 1 from the left of f of x plus g of x. And so that's going to equal, well, let's take a look. As we approach 1 from the left, f is, let me put the equal sign down here. As we approach 1 from the left on f, we get 3. Plus, as we approach 1 from the left for g of x, we get 1. So that's 3 plus 1, which is 4. Then let's try the right-hand limit. So the limit as x approaches 1 from the right is 1 for f of x, plus for g is 3, which guess what is 4. So since the right-hand limit and the left-hand limit are both the same and they're 4, we could say that the limit as x approaches 1 for f of x plus g of x is actually 4 because it's approaching the same thing from both the left and the right. And there's a practice problem there. We could do that in class. Same with that whole entire right column, but those are more or less the examples you need.